Here is Precal. It's number 9-79, and it wants calculate the area of a parallelogram defined by these two vectors. Okay, so I'm not sure if we did one of these in class or not. I'm not even sure if there's a math notes box for this. It might just be somewhere in one of the exercises where they kind of showed you that. But basically, I have a little formula for it in my magic book. So I don't know if you remember that time we learned about the area of a triangle. There's a little formula for getting the area of the triangle using vectors, which is very cool. So the parallelogram kind of comes from that because, well, it just doesn't have the half on it. So this is hard to read. I wrote it up here. Here, it's right here. Area of parallelogram. I rewrote it because it was messy. So this means you can take these two vectors. They'll just give you two vectors, and I'm going to explain to you why there's only two vectors, and they're saying it's a parallelogram. But basically, this you should write this down and keep it somewhere or something. Put it on your cheat sheet. This means it's the determinant, because see how there's no little, if it was like this, that's just a matrix. But when it's like this, that means it's the determinant. And if you remember, we learned a while back how to get the determinant. Determinants, you go the top left times the bottom right minus the other diagonal. So that's why I've written it like this. So this is just saying if I have two vectors that can form a parallelogram, all I have to do is plug the numbers in here and do the math. So I'm going to take the determinant of a matrix that is made out of the first ordered pair, or the first vector, and the second vector. Okay, so I just threw these numbers in right here. That's x1 and y1, and I threw these numbers in right here. And then negative 4 times 15 made 60 minus 6 times 5 is 30. So that's 30 square units. But you might wonder, well, that's a cute trick. Why did that work? So I tried drawing the vectors. They look pretty bad because I didn't use graph paper. But this is negative 4 comma 5. I start at the origin. I go left 4 up 5. And then this is start at the origin and go right 6 down 15. Right 6 down 15. You'll notice I didn't space my units very well, so it looks like it's a straight line, but it's not. There's a little bend right here. Okay, and then so it only takes two vectors to define a parallelogram. The book told us it's a parallelogram, so that means there's two other parallel vectors. Like there's a vector exactly like this one down here that starts here, and it's right here. This vector and that vector are parallel, and I put that vector there. How did I do it? I started here, and I went left 4 up 5. I went left, hopefully I went left 4 and up 5. Okay, and then if I want to place this vector in, well, this goes, I'm going to start it up here so it actually forms a parallelogram. So this will go right 6 and down 15. Or I don't know, I just think it's going to go like this. So how was that? Is that right? 6? Let's see. Yeah, that's right, 6. Sorry, right 6. So from here, it's right by 6 and down by 15. So anyway, and I want you to understand the concept behind it, but some of you are probably just gonna say, "Oh, there's the formula." Every time I see that, I'm gonna open up my magic book and plug the numbers in. So that's how you do 9-79. That actually is a nice, cute little trick to find out the area of this ugly parallelogram.